Okay, so now this is a problem we have in textbook. Applications of concept second bit. This is the second question. 50 meters. What is the length of the train? 50 meters. It is moving with a constant speed 10 meters per second. So what is the speed of the train? 10 meters per second. So two things are given. Length of the train is given. Speed of the train is also given. Now we have to calculate the time taken by the train to cross an electric pole. Where is the electric pole? That is at the very end of the bridge. This is a bridge. Okay, just imagine this is a bridge we have. Okay, now train is passing over the bridge. Here it is a train. Okay, right, this is a bridge. What is the length of this train? 50 meters. And what is the length of the bridge? 250 meters. Okay, here there is an electric pole. Imagine this is an electric pole. Okay, I draw the electric pole with a different color. This is electric pole, right? Now when this train is passing over this bridge, we have to calculate the time taken by that train to cross an electric pole. So this train should cross the electric pole. Okay, that means the last compartment of the train should cross the electric pole this way. Now train is crossed. Okay, train is crossed electric pole. During this, what is the distance traveled by the train? The distance traveled by the train. Okay, we have to take only 50 meters because 50 meters of the length of the train crossed bridge, crossed the electric pole. So what is the length of this train? 50 meters. Okay, so the engine onwards, the last compartment, what is the length? 50 meters. So whenever a train crossing this electric pole, what is the total length of the train crossed? 50 meters. So length of the train is equal to 50 meters. So totally the distance crossed, the length crossed by the train is equal to only 50 meters we have to consider. Now in this case we have to calculate the time taken by the train to cross the bridge. Okay, so speed is equal to distance by time. Time is equal to what, Nana? Distance by speed. This is the formula we are using. Time taken to cross the bridge, T is equal to distance traveled is 50 meters, time taken is 10, then T is equal to 5 seconds. It is time taken to cross the bridge as the electric pole. Next in this question only they are asking time taken to cross bridge also, electric pole and bridge also. So here length, what is the length of the bridge? 250 meters. What is the length of the train? 50 meters. So this 250 meters and this 50 meters total. What is the length now? 250 meters plus 50 meters, 300 meters. So the distance traveled during the crossing the bridge is 300 meters because 250 meters is the actual length of the bridge and 50 meters is the length of the train because total train has to cross the bridge, right? That is why together 300 meters. And time should be calculated. T is equal to question mark and the speed of the train already same, that is given 10 meter per second. So same formula, time is equal to speed by distance by speed. Time is equal to what is the distance traveled here? Distance traveled is equal to 300 meters. Okay, speed is equal to 10. So T is equal to here 30 seconds. To cross the only electric pole, here train is crossing the electric pole. What is the length of the train? 50. That is why here the distance is taken only 50. Here the train crossing the complete length of the bridge, not only the engine, the complete compartment, at the last compartment also should cross the bridge. Then the length of the bridge and the length of the train together 300 meters. Okay, in this way we have to consider, and this is the answer. Time taken to cross the electric pole is 5 seconds. Time taken to cross the complete length of the bridge is 30 seconds. This is the answer for this. Please note down. This is the sixth problem in applications of concept which we have in improve learning. A car travels at a speed of 80 kilometers per hour during the first half of the running time and 40 kilometers per hour during the other half. Okay, so let the time taken by the complete journey is T. So here half of the time during the first half of the time, the speed of the vehicle is 80 kilometers per hour. Next, during the second half of the trip, the speed of the car is 40 kilometers per hour. Okay. So what we have to calculate? We have to calculate the average speed of the car. So to find the average speed, actually we learnt three formulas. Okay. So what is the formula we learnt? Generally, average speed is equal to total distance by total time. Here journey divided to two parts. So we can use S1 plus S2 by T1 plus T2. But S1 and S2 is not given. To find the S1 and S2 value, again substituting in that formula, it takes time, lengthy process. But already we learnt shortcuts. Whenever half of the time with one speed, half of the time with the other speed, the derivation already I gave you. To calculate the average speed in this particular case, we have another formula, that is V1 plus V2 by 2. This formula we use when that vehicle goes with a speed, okay, during the first half of the journey time, goes with other speed during the second half of the journey time. At that condition, we have to use this formula. And one more formula also we have discussed, because I am revising that. Half of the distance one speed with one speed and half of the distance with other speed, we use another formula, that is average speed is equal to 2V1 V2 by V1 plus V2. So total these three equations we have discussed to find the average speed. Now tell me which is the suitable, that means which it is a time taking process. If we use this formula, it is a time taking process, but this is very easy because we have V1 value and V2 value. So what is the V1 value? 80 kilometers per hour. What is the V2 value? 40 kilometers per hour. Okay. Now we have to calculate the average speed. Average speed is equal to this formula we are using, V1 plus V2 by 2. When do we use this formula? Half of the time with one speed, half of the time with the other speed, we use this formula. So V1 plus V2 by 2, 80 plus 40 by 2, 80 plus 40, 120 by 2, that is equal to 60 kilometers per hour. Okay. So this is easy method. That is why learn these formulas, this formula and this formula. Okay, please note down this. Lesson has been finished so far. We discussed complete all the concepts in this lesson. Now this is improve your learning. Okay, what is the first question we have? So this is the discussion part. Most of the times the question what we discussed, what we are going to discuss now, this has been already finished in the previous videos. So I just refer those videos to watch, please, because it is not the teaching part, it is only the discussion. Okay, so already when you have gone through those videos, when you are coming to this discussion, you will understand what is what. So that is why after watching those videos, please watch this video. Okay, so distinguish between speed and velocity. How do you find which is speed, which is velocity? So the major difference between the speed and velocity, okay, speed is a scalar quantity, velocity is a vector quantity. Okay, so how do you write the answer in the exam? Speed, velocity. You have to write this way. Okay, next you have to write the first point, you have to write the definition of the speed of the light, speed. In this first point, you have to write the same definition of velocity. Okay, what is the definition of speed? The rate at which an object covers a distance is called speed. The rate of change of displacement is called velocity. Okay, second important thing is it is a scalar quantity because it has no direction to describe, but velocity is a vector quantity. It is a vector quantity. Already if you have watched videos, can you guess what is the next point I am going to say? Yes, speed is always positive, but velocity can be negative also. When displacement is negative, velocity also negative. How is this possible? See, I'll explain with one example. This is recalling. Let's say an object starts at point A, traveled towards B. This is the initial direction, and he returned and reached the point C. So first he traveled towards A to the B 10 meters, B to the A also 10 meters, A to the C 5 meters. So the total time taken to travel is 2 seconds. Okay, let's say the total time taken by that person is standing at A and he is traveling towards B and he reached A and he crossed A also, and he traveled opposite direction to the initial direction up to the C, more extra 5 meters. Now we have to calculate the speed. Speed is equal to what now? Distance by time. A to the B. First A to B he traveled. How much distance? 10 meters. Next B to C, B to A also he traveled. Again he traveled A to the B as well as B to the A also. So more 10 meters. He doesn't stop at A. He traveled from A to the C also. He crossed A and traveled more extra 5 meters. Okay. Total time taken is t seconds. Speed is equal to distance by time. 25 by 10 is equal to 2.5 meter per second. Okay. But displacement, what is the displacement? What is the initial point? What is the final point? Initial point is A, final point is C. What is displacement definition? It's a shortest distance between the initial point and final point. So the distance between the initial point and final point is 5 meters. But the direction of this displacement is opposite to the actual position, so it should be taken as negative. Okay. So actual direction, initially when object travels, actual direction is towards east, but at the end he was turned towards west. So direction of the object is changed. So direction is reversed. So this negative sign indicates there is a change in the direction. So direction is reversed. Okay. So displacement is 5 meters. Time taken is 10 seconds. Now it is minus 0.5 meter per second. What is the displacement? What is the velocity? Sorry. What is the velocity? Velocity is equal to displacement by time. Displacement is equal to 5 meters. Velocity is equal to displacement by time. Displacement how much here? Minus 5 meters. Time how much? 10 seconds. Together minus 5 by 10, 0.5 meter per second. This is minus. Plus by minus is minus. See, velocity is negative in this case. That is why velocity can be negative. Okay. And a last point. Speed never be zero. Always it is something. It has some value. But velocity can be zero. Velocity can be zero. How can we explain this one? I explain with one example. See, let's say a man traveling in a circular track of radius 14 meters. He started at point A and he covered circular track and he finishes one round and reached the same point A. Now what is the distance traveled? 2 pi r, that is equal to circumference of the circle. Okay. 2 into pi value 22 by 7 into what is the r value? 14 meters. 7 ones, 7 twos. Total 88 meters he traveled. Let's say he has taken 10 seconds to complete this round. Then what is speed? Speed is equal to what here? Speed is equal to distance by time. What is the distance? 88 meters. Distance is 88 meters by time 10 seconds. So 8.8 meter per second. This is the speed. But velocity is equal to displacement by time. Displacement by time. What is the displacement in this case? He started at point A and finally he reached the point A. Initial point and final point both are same. When initial point and final point both are same, the displacement value will be 0. So 0 by something also 0. So in this case velocity is 0. Okay. So I hope you understand the major differences between the speed and velocity. So in this way you have to write the answer whenever this question will come in exam. Okay. Right. The second question, briefly explain about constant acceleration. Acceleration must be same. Acceleration must be uniform. Okay. It should be constant. So in which case it is constant? Let us understand. Okay. So let's say this is a small trip. A, B, C and D. I have chosen 4 different points. Okay. At 6 a.m. the vehicle is here. The vehicle speed is 10 meter per second. The practical unit I will use 20 kilometer per hour. The speed of the vehicle at point A 20 kilometer per hour. This vehicle is reached point B. Its speed increased, velocity increased. Assuming this object is moving in straight line. Okay. Right. Speed increased to 40 kilometer per hour. At point C again speed increased 60 kilometer per hour. What is the speed? Speed in one direction is called velocity. What is the velocity of this? At point C 60. At D 80 kilometer per hour. Let's say At point A time is 6 o'clock, at point B time is 7 o'clock. By reaching point C the time will be 8, and by reaching D point will be 9 AM. Okay, AM. So what is the interval? What is the time interval? 6 and 7, 1 hour. What is the time interval between 8 and 7? 1 hour. What is the time interval between 9 and 8? 1 hour. Now you have to calculate the acceleration between A and B. Acceleration is equal to change in velocity by time. What is the change in velocity? 40 minus 20. 20 by time 1 hour. So the acceleration is 20 km per hour square. Now we are going to find the acceleration between B and C. Acceleration formula, change in velocity by time. Final velocity minus initial velocity by time. 60 minus 40 by 1. 60 minus 40, 20. 20 by 1, 120 kilometer per hour square. This is the initial velocity, this is the final velocity. When we talk about this acceleration between A, C and D, change in velocity by time. What is the change in velocity? 80 minus 60. Okay, that is equal to 20 by 1 kilometer per hour square. 20 by 1, how much? 20. Okay, see, what is the acceleration between A and B? 20 kilometer per hour. B and C also 20 kilometer per hour. C and D also 20 kilometer per hour. What do you understand here? Here velocity changing, okay, equally. Here A to B how much changed? 20. B to C 20. C to D 20. Every time velocity changing equally in equal intervals of time. Whenever if velocity changes equally in equal intervals of time, we say that object is moving with a constant acceleration, because acceleration of this object is constant every time. So this is example. So the definition and more examples we have discussed in the previous video. Okay, right. If you want to explain the answer, you can take such kind of example and you can explain in the exam. Okay.